All right, let's try another solution here. And again, I get the impression again, a few of you are struggling with this word elastic and inelastic. And so maybe go back and look at the lecture videos, maybe the reading, maybe go back at my solution to number 24. And I think it's some other solutions. But I just want to emphasize, when two things collide, their momentum is conserved. Always. It has nothing to do with that word elastic or inelastic. Let's read this one. This one says a 1.8 kilogram falcon catches a 0.65 kilogram dove from behind in midair. All right. So we've got one bird flying, and that's the predator. So here's my falcon, which is the bigger one, 1.8 kilograms. And it is going to be flying faster. I'll keep reading to see how fast it's flying. But it sounds like, because it says here, it catches a 0.65 kilogram dove, so I'll put D for dove, from behind in midair. So this tells me the dove's kind of racing away. So we got predator and prey here. What is the velocity after the impact if the falcon's velocity is initially 28 meters per second and the dove's velocity is a mere 7? Okay, so again, reading into this problem, so I'll go ... Afterwards, if predator is able to catch its prey, they're hanging on. They're stuck together. There's an interaction here. And let me just repeat. Elastic means that there is no bumping and rubbing of the molecules. Actually, sorry, what it means is the kinetic energy before is equal to kinetic energy after. So not knowing if it's elastic or inelastic, because they haven't told me, and that doesn't matter for momentum, I'm going to begin this problem by just say the momentum before is equal to momentum after. And speaking of after, I should have put here, I'm going to then think of that as one big object now that the two have combined together. And so I will have one object that would have a mass that, let me just add these together, 8 and 6, 14. Okay. So this is the mass of the two together moving at some unknown speed. And I'll put it again. I would say conservation of momentum. And again, that has nothing to do with the words elastic or inelastic. Inelastic means kinetic energy is not conserved. Elastic means it is. And elastic is kind of rare. Most of the time when two things hit, they bump and rub. But there are cases, especially if they're a real hard object, they can actually bump and they kind of spring off of each other. And there is no rubbing. It's just kind of a compression and pushing back. And therefore, the kinetic energy afterwards is the same as before. But that would only work if they didn't stick together. So I guess what I'm really saying is if they stick together, we know it's inelastic. So I would cross this out just because they said they stick together. But actually, I would also cross it off just because they didn't tell me it was elastic. It's kind of a rare case. So don't assume it unless they say something about it. All right. So, and it turns out I don't even need that to do the problem they have, because this would be the momentum before. So here's the falcon, and the falcon is moving, at 28, and the dove, which is a smaller mass, is moving at 7. So there is the momentum of the two. And that would have to equal the momentum of the two after. Now, I'll say the two, but I'm just going to treat it as one object. They just kind of added together. And now I punch in my numbers here. Okay, so 1.8 times 28 plus 0.65 times 7. And that's the momentum before the collision. And again, it's got to be the same after. So if I divide that by the mass of this one giant object, I will get a speed of 22.4. And we're not asked to do this, but I think there are some other homework problems where then you're asked to go ahead and then calculate the kinetic energy before. And you can do that now that we have well, before and after. We could already do it before we even did this calculation, what the initial kinetic energy is. But we can also, now that we got the final speed, get the kinetic energy after. And you'll see they don't equal each other. You will see that the kinetic energy after is less than before, and that's because there was some bumping and rubbing going on. But the fact is, if we just calculate kinetic energy before and kinetic energy after, like we can do, we will see that there has been a decrease in kinetic energy. That's because there's some heat created. So total energy is conserved, but not the kinetic energy. So we would have to say, by proof here of doing first conservation of momentum, get the speed, then doing kinetic energy, that they don't match. And so that's what you're asked to do. I think there's one at 2 dimension, you're asked to calculate the kinetic energy before and after and show that it is elastic. And so that one does come out to be elastic. They're 2 pool balls, and they don't stick together. They just kind of come in and bounce off. Okay, well, hope that one helps too. Bye now.